Welcome to Maths with EJD. In this video, I'll be talking about data visualization. Interestingly, from now to, for the next 5 or 6 videos, I'll be talking about different data visualization tools, but not until I've talked about a general idea about these things, what data visualization is about and all that. And it's a very exciting part of data analysis, by the way. So straight up, visualization is the process of presenting data in a graphical or pictorial format that allows people to quickly and easily understand the patterns, trends, and insights contained within the data. So, when you have data, some data at first sight, you can already see some patterns, but most of the times you don't get to see the details, what the data is about until you have visualized it, right? And just like they say, a picture is worth more than 1,000 words. So data visualization is what paints a vivid picture of what your data looks like for you. So data visualization is a powerful tool for exploring and communicating complex information as it can make data more accessible, engaging, and memorable. So data visualization is used in a variety of fields, including business, science, healthcare, journalism, education. Some common applications of data visualization include exploring data to uncover patterns and insights, communicating data to a non-technical audience. Only few people can actually see the data, the raw data, and try to get some sense out of it. You know, but everybody can relate with the picture you draw based on a particular data set. So people can see when things are increasing or when things are reducing or when things are static for sure. So you can communicate easily with a non-technical audience using data visualization. Okay. Communicating data to a non-technical audience. Okay, I've said that just now. And then presenting data in a clear and engaging way. That's implied in what the things I said. Identifying trends and outliers in large data sets. So one of the things you do, after getting your data is you clean and then you do exploratory data analysis. That's trying to get familiarized with your data set. So at that point, you can already see trends like what is increasing, what is reducing, the seasonality and things like that. So you can easily see outliers in large data sets. So monitoring key performance indicators in real time is also helpful. So you can see what key thing is. It's just like an election is ongoing, and then as the results pour in and it's being updated per time, you can already know. Based on the rules of election, right? You can already know based on the number of states won or things like that. So at that moment when a clear winner emerges and all that, right? So overall, data visualization is an essential tool for everyone working with data as it can help to unlock the insights and stories hidden within the numbers. So Python is a popular programming language for data visualization due to its flexibility, ease of use, and wide range of libraries and tools available. So here are some of the most common libraries used for data visualization in Python. Matplotlib, that's the most popular and the most important one, if you ask me. So it's a powerful library for creating static, interactive, and animated visualization in Python. It offers a wide range of customizable options for generating plots, such as line graphs, scatter plots, bar charts, and pie charts. Then going after that, we have Seaborn, which is, by the way, built on top of Matplotlib. So Seaborn provides enhanced features and attractive style for sophisticated statistical visualizations. Things like if you want to see margin of error, heat maps, you can only do things like margin of error, heat maps, volume plots, and all that in with Seaborn. You can't do that with Matplotlib. But Seaborn cannot function fully without Matplotlib, by the way. So Matplotlib is still the most popular and the most important visualization library in Python. Then there's Plotly, which is a versatile library for crafting uh, interactive and dynamic visualization. So if you want interactive visualizations, Plotly is your go-to place. So such as scatter plots, line charts, and three-dimensional surface plots. Plotly also supports the creation of interactive dashboards and data-driven web applications. So if you are talking about data-driven web applications, Plotly is your go-to visualization tool. Or you want to talk about dashboards, which the closest we know to about dashboard before now would be using tools like Power BI and Tableau, right? So Plotly is the answer to all that in Python. So there's Bokeh also, which is focused on creating visually appealing and responsive web applications. So Bokeh offers an extensive toolkit for building interactive visualizations, including line charts, scatter plots, bar charts, and histograms. And then we have Altair, which is a declarative visualization library designed for simplicity and flexibility. Altair integrates seamlessly with pandas and supports a wide array of chart types like scatter plots, bar charts, and line charts, allowing users to construct complex visualizations with minimal code. Then there's this very interesting one, which is Plot9. There's this ongoing debate about which is better between Python and R, right? And most times, one of the key things people give about the superiority of R to Python is the fact that it has ggplot, maybe the visualizing can be very beautiful compared to R, compared to Python. But guess what? Plot9, it comes into play here. But Plotman is actually a Python implementation of the grammar of graphics, which is inspired by ggplot in R. So with Plot9, you can actually get ggplot standard. You can get R standard visualization right inside of Matlab, right inside of Python. All right. So I mean, so you can enjoy some R benefits right inside Python with Plot9. So Plot9 allows users to build complex plot by combining independent components, making it ideal for creating layered, multifaceted visualizations with an expressive and intuitive syntax. Okay. And these libraries are just a few examples of the many powerful tools available for data visualization in Python. By combining the right tools and techniques, you can create compelling visualizations that help you explore and communicate your data more effectively. All right. So going forward, we'll be focused. So for the rest of this video, I'll be taking you through the whole Matplotlib visualization, data visualization with Matplotlib. So, and then after now, I'll take each of these libraries one after the other as we go through it. So let's move on to Matplotlib now. So Matplotlib is a powerful Python library used for creating high-quality visualizations, ranging from simple plots to complex 3D visualizations. And of course, with every other kind of library in Python, the first thing you want to do is to install. So the installation, Matplotlib can be installed using pip. Now, most of the times, any library you want to install in Python, you have to use pip. So you say pip install, then the library, right? Here it's pip install Matplotlib because I had it before. Of course, I'll just try to like, okay, I mean, let me zoom out now. Come to that point. So pip install Matplotlib. I just press Control Enter, and you see that star. It shows that it's running, and then this says requirement already satisfied. So if you are running it for the first time, right, it will take a bit more time, and then by the time it's done, it will tell you that you have now installed Matplotlib. So having installed it, the next thing we want to start, we jump into it directly. So we want to now begin to use, like, let's imagine we want to do a basic plot in Matplotlib. So let's start by creating a simple plot of a sine wave, right? So here you need Matplotlib, right? So you import matplotlib.pyplot as PLT. So imagine each time you have to access a function inside the library, you have to write the library first, dot the function. So imagine you have to write matplotlib.pyplot dot whatever you are bringing. For instance, you see PLT plot here. To plot, you need matplotlib. So imagine each time you have to write matplotlib.pyplot.plot, matplotlib.pyplot.show. And that is why it is important to import it as an alias, which is usually plot, PLT, or you can call it PT, you can call it PL, you can call it whatever you like. But just make sure that you don't, whatever you call it, you always use it. But PLT is more like the conventional thing used. But the alias can be whatever, as far as you always use it that way. Okay. So in this case, you're also going to import numpy as NP because, of course, we need functions like linspace, even sign. Those actually come from numpy, right? So here, of course, we have for a graph, right? For a plot, you need the X and Y axis. So for the x-axis, now that is the independent variable. So you supply that, and the y-axis automatically builds on that to follow its rule, right? So here we have our x is np. So line space comes from numpy. That's why we need numpy up here. So and then it's from 0 to 2 pi. So pi also comes from numpy. That's why we have two times pi coming from, because if you say 2 times pi, it doesn't work. So it has to be 2 with pi coming from numpy. So from 0 to 2 pi divided in 100. So linspace is to give you equal division of this 0 to 2 pi. So this 100 tells you are dividing 0 to 2 pi in 100 divisions, right? So you can have like a very fine graph. And y here tells you we are going to plot, we need sine x as we impute this x and we get sine x out. And line 7 is where the actual plot is coming. And that's where Matplotlib begins to become useful. So plt.plot, so it plots x y against x-axis, and then plt.show is what actually shows the plot, right? So if I press Control Enter now or Shift Enter, it gives me the plot. So see what the plot looks like. So these are our sine plots. Okay, I mean typical, right? So in the code above, we first imported the matplotlib.pyplot module and the numpy module. We then created an array of 100 equally spaced. So anytime you see linked space, it's wants it to be equally spaced based on the last value you have here, like this 100 here. So yeah, spacing 0 to 2 pi equally in 100 divisions, equally spaced between 0 and 2 pi using the np.line space function. We then calculated the sign of each value in the array using the np.sign function as we have in line 5, right? So finally, we plotted the array against we plotted array x against array y using the plt.plot function and display the function using the plot.show function as you see in line 7 and 9. So that's why we have that. So how about if you want to set plot properties, like you want to do other things on the plot, we can set various properties of the plot, such as the plot title, axis labels, legend, etc. So let's add the title and axis labels to the plot we created earlier. So you see, this is just a simple plot with no label on the x or y axis. We just have this plot, easy. So declare the x, declare the y, and plot x against y and show it. That's all. So, but here now we are taking it a step further. So beyond the plot and the show, now we are now saying plot title, want to call it sine wave, x label, we say x axis. So if it is something, if you're maybe it is nutrition and weight, you can just put that here. Anything in red comes out just exactly the way it is when we talk about string variables, right? Like you must have seen, I think in the first few videos in this playlist. So see what we have now. So the addition are in lines 9 to 10, 9, 10, and 11. Every other thing remains the same, but now we are labeling our graph. So that's what it means by setting plot properties. So if I run this now, so it shows this. So what has been added? Sine wave is now added, y-axis, x-axis. So you could change it to whatever you want to change it to. Say, okay, like I said the other time, let's say instead of sine wave now, we want to say maybe we have a particular thing. Okay, I think I want to create a new cell for this. All right, escape below. Okay, and okay, I think it should come after this. Good. So, okay, okay. I think let me do this now. Escape twice. Then I put this here. So, but before I do this, right, I need to put this back up here. This now. So we have this done, and then this comes. So because this explains what we have at the top, and this is actually okay, it's markdown. So I escape and I press M to put it in markdown. I enter. Okay, good. So we have this now. So in the above code, we added a title. We added a title to the plot using the plt.title function and added labels to x and y axis using the plt x label and plt y label functions. So x label, y label. That's how you get x label, y label like that. So what I just want to do here is I want to maintain the same graph, and I want to say the graph of weight, let's say weight against nutrition. So that's the title. I maintain the same sine wave. So I say this is, so x-axis is the nutrition, and y-axis is the weight, right? So nutrition determines weight, for instance. So if I do this, so I mean, it's the same graph, but I've just relabeled it. So if you can always do that kind of thing. So how about you want to have you want to plot multiple lines. You want to plot multiple lines, see what we have here. So instead of just sine graph, you want both sine and cosine. So we can plot multiple lines on the same plot using the plt plot function multiple times. So here now, the same plt plot you've used up here, this line 7, instead of using it once, you want to plot multiple. So you use it, if you want 5 plots, you can do it 5 times, right? So here now it means we still have the same, for instance, we want to do sine and cosine together. So we still have our x normally. We have y1, which is np sine x, which you knew before. So instead of just calling it y, we say it's y1. This is now y2, np cos x, right? So we now use the plot. We say plot x against against y1, plot x against y2. Before it was just plot x against y. But now we even so since there are two now, we now need to label to know which is which. So the first one we label sine x, the second we label cos x. The first one we say it's color blue, the second one we label it color red to differentiate, and then we have line with 5 for each. We can adjust this line with based to your taste, right? So I want after running this, I'll do some adjustment. So the plot title is now sine and cosine waves. Then x label, y label is x and y here. Now we need legend because we now have two different lines. So we need legend to distinguish between the two. And then we plot, we want grid. If you want grid lines, you say true. If you don't want grid lines, you say false. And then you can show it. So if you run this now, so you see this beautiful graph you get now. So what happens if I say, if I remove this plot grid, right? If I just comment this out and I run again. So you see the lines are gone. Or if I don't want that, I could also, I don't have to comment. Instead of true, I just say false. That means I don't need grid lines. But sometimes grid lines actually, oh, this isn't working. False, right? Okay. So if I don't want it, I just comment it out. Okay. So Control Z, I'll just say true. So if I want grid lines, so the grid lines are here now. All right. So look at the line with 5. So if I want maybe I want the sine graph to be smaller, I can just make this 3 and the line is smaller, right? If I imagine if I want this to be 15, that would be crazy. Now you see how big that is. So you can adjust your line width like that. So let me take you back to 5 that they both were initially. So this is what we had there. Okay. So, I mean, you can read all the story later, but I mean, the story has been told. All right. So here, let's imagine we now want to do, we are trying to do some extra stuff, right? You know, import Matplotlib. So here we have, we want to increase the figure size and resolution for better print quality. So I'm going to talk about this later. But figure size, now you can determine the size. You say this is 5 by 3, and the dot per inch for printing, that determines print quality. So we say dot per inch is 300, and then you have the usual thing. 0 to 2 pi divided into 100 equal divisions. Then you have y1 is sin x, y2 is cos x. Then you now see a PLT plot, the title, the x label, the y label. We say angle and trigonometric ratio now. So we say plot legend, font size is 12, then add grid lines if you want. So this is like more elaborate stuff. So draw a line at the origin. So here now, I don't want to draw a line at the origin, right? And sine curve passes through the origin. Cosine curve is at 1 at the when at x equals 0, right? So then you can increase the font size of the axis labels and legend and all that. So we have more things going on here. So if I run this now, you have something more elaborate. Okay, you have something more elaborate like this. You have something more elaborate. See all the plenty things we have here. And then this is the graph that gives. Okay, so we have something that elaborate. So you see the line drawn from the center, and you see the blue line, which is the sine line passing through. So you see blue is sine, so it's passing through the origin, but at that point, the cosine graph is at 1, as we know. All right. Okay, so that's fine for simple plots like that. How about we would go for plotting a histogram? A histogram. We can create histograms using Matplotlib. Let's create a histogram of 10,000 normally distributed random numbers. So here now we are using random. You just want to, so if anytime you use something random like this, it means each time you run it, it's going to give you different shapes because you're just taking, we want to create a histogram of 10,000 normally distributed random numbers. That means that the mean is 0 and the standard deviation is 1, I think. Yeah, for normal distribution. So here now we just have this. See what that is. In the above code, we use the np_random.normal. So you see what is doing the actual plot here is this 6 plot histogram x beans 50. Then x is np.random normal. So because it's random, anytime I run it again, it gives a totally different shape. See, the shape keeps changing because it's generating different random numbers, right? So of course we know all the other things, title, y label, x label, and all of that. So for this bean, now you may wonder, what is this bean about? So what if I make this bean 5? What does it look like? So bean is about the width of the rectangle for each histogram. I mean, for each of the bars, right? So histogram is just like bar chart that is joined together, basically. So the bin talks about the size of the bar. So the smaller, the bigger, the smaller. So if I make it 50 now, it's like you have smaller divisions of all of these things, right? So that's that. So in the above code, we use the np.random.normal function to generate an array of 10,000 normally distributed random numbers with a mean of 0 here and standard deviation of 1. We then plotted a histogram of the values using the plot.hist function and added the title and axis. So you see what is doing the main work here is this plot plc.hist. Like for the other one, we had plc.plots. And here now we are plotting just X because it's histogram. And Bean talks about the size. So if I make this 500 now, it's going to be really tiny. You can see it's really, really, really tiny. Okay. So that's what the bean does. Okay, so let's take it back to what it was initially. So we have this. Okay. So how do you also want to plot a scatter plot? A scatter plot is one of those ways you can easily get a kind of correlation picture, of two variables. So we can also create scatter plot using Matplotlib. So let's create a scatter plot of 100 random XY coordinates. So X is random, Y is random. So anytime you see a random dot normally distributed random numbers, it has each of them comes from the NumPy library, and that's why we are bringing NumPy in. By the way, if you have imported Matplotlib before now and NumPy before now, we don't have to keep doing it. But I mean, sometimes I just do this just for the sake of newbies who may forget to run that initial one, and they get error messages that may be very frustrating. Okay. So here now X is random from between 0 and 1. Y is also random between 0 and 1. So we just plot them against themselves like that. And the real thing here is plot plc.scatter. So scatter is a function inside the matplotlib library that does scatter plots. So we've seen plc.plot, plc.hist. Now we have seen plc.scatter inside of matplotlib, and then we have the title and all of these other things. So this is it now. So this is one. So here you can't see any clear pattern because all the points are all over the place. So if I do this again, so I keep doing this, and the values keep changing. So it looks like we can't really seem to get any correct pattern. But never mind. We'll get to a point where we actually upload a data set and then we get something more beautiful. So I mean, just like I also said, you can create a you can just I mean this you can create Python lists and do scatter plots with them. So maybe you have students in the Department of Pharmacy or Faculty of Pharmacy, and they take courses like pharmacy and pharmacology, and you have their scores here. So this is a self-generated data, for instance, and then you can plot the scatter plot of pharmacy against pharmacology, and then you put the titles and all that. So you run this, see what you get. So by the way, this is what this is about right here. Okay, so here there's no clear pattern also because the values are just all over the place. But then it's looking more like a negative slope, like the higher you score in pharmacy, the lower you get in pharmacology or something like that. I mean, but we may need to draw a line of best fit to be really sure about that, right? So that goes. So we can also have three-dimensional plots. Like Matplotlib also support three-dimensional plots. Let's create a 3D surface plot of a sine wave. So for a sine wave now in 3 dimensions, we now need, apart from Matplotlib and NumPy, we now need in addition, we need a library called the MPL toolkits. So from that, we are going to import mplot 3D, like a function inside of that library. Though here now, because it's 3 dimensional, we have to also define the fig. So fig is equal to plot plc.figure. So this figure is a function from inside matplotlib, and then we also have to talk about the axis too. So with plc.axis, and projection is in 3 dimensions. So here we need, for 3 dimensions, right? You need two independent variables, x and y. So just like because 0 to 2 pi divided in 100 divisions for both x and y, and I have x comma y with a mesh grid XY. So things are a bit more complicated because we're talking about 3 dimensional stuff, which is like a surface plot. Then Z now it will now be the sine of that, right? So you now have np dot sine square root of x squared plus y squared. And then you now have axis dot plot surface. So this plot surface is coming from this AX up here, right? So, and you have XYZ CMAP rainbow. Now, this CMAP there are many other things you can change it to. And I'm going to play with a bit of some of them so you can see the things you can do here. And you can set axis to be sine wave in 3D. That's axis title. There are 3 axes here. So axis set title, everything together, you have this axis set X label, Y label, Z label, and then you show. So if you run this now, see what you get. So that color is determined by the fact that our color map is rainbow. So there are other maps, other ones like Viridis. There's Viridis, that's this kind of thing. There is CVDs, CVDs. I mean, I've worked with them a couple of times. That's why I know them. So you can always Google different color maps. I know there is also there's Cool Worm. Okay, there's Cool Worm. This is what Cool Worm looks like. There is what else is there? I think there is you can have greens. So it gives you shades of green like this. You can have blues. You can have blues. Okay, like that. So, but I think I tend to like there's so many more, like so many. So I seem to like rainbow sometimes, all right? So this is for rainbow now. So you can change all those colors. In the above code, we first imported the MPL toolkit.mplot 3D module in addition to the matplotlib.pyplot and numpy modules. Now we've come to that point now where we want to work with imported data, like you have an external data, Excel, CSV, JSON, and then you want to you want to do some matplotlib plots using those kind of things. I know this is one exciting part for everybody. So here, importing data. Let's start by importing the CSV file. Working with imported data is a common task in data visualization using Matplotlib. So importing data, let's start by importing a CSV file containing some sample data. We'll use the pandas library to read the CSV file and create a data frame object, right? So, I mean, just like I've always told you, we are using a 50 startups data set now. I think it's a data set that is common. You can find it on Kaggle or many public repositories like that. So far, take note that there are no plots here. The only thing that looks like a picture so far is this my this is my thumbnail. That's the only thing that is a plot. We are going to be doing some plots along the line, and you're going to see now, no, we've done some plots already, but they are not here right now because we didn't save them. So if you want your plots saved, we are going to talk about that towards the end of this video. So when you save the plots, each plot we save, I'll come back here to check to show you. So right now we don't have anything saved as a plot apart from this. This is not even a plot. This is just a thumbnail for a thumbnail. So this PDF document too is like the first the presentation I made as an opener for this playlist. Okay, so there are no plots here. That's just then the 50 startups. So you can open the CSV file. I think it's a CSV file, by the way. Yeah. So and look, so you can quickly appreciate what it looks like, even in this raw form, even before you start converting it into a data frame. So you see, we can even. I mean, this doesn't affect anything. I just like to be I just like to do some extra sometimes. That's all. So you have 50 startups, and we have the research and development spending, administration spending, marketing spending. That's the amount they spend on marketing. You can imagine this 20th startup doesn't spend anything on marketing. And we have different states like New York, California, and Florida. Those are the three states, and we have their profits also, right? So even with no marketing spend, this startup still makes some profits, right? So we have some other ones that don't have other kind of spending, right? Those zero values. Okay. So that is what this data set looks like. And that's what we're using in this case for the most part. Of course, we'll also be maybe making some simple inputs here and there sometimes. Okay. So look at this now. We're importing. So we just say, since it's the CSV file, we say df is equal to pd.read underscore CSV 50 underscore startups dot CSV. By the way, be sure that you use exactly the name with which the file is saved, and make sure that file is in the folder where your Excel, where your code sheet is. So see my code sheet here. This code sheet for what is it? For data visualization with Matplotlib. So be sure it's in the same folder. So this one now, it's data visualization with Matplotlib. See it right, this one now. So it's here. So you have to make sure they are all in the same folder. Everything you're using, they are in the same folder. If not, you can have some errors. It can have something like maybe okay, for instance, instead of saying startups, I just say startup. So if I run this, it's going to give me error because there's nothing like 50 underscore startup in that place, right? So you have to be careful about capital letter, about letter missing and things like that. So, but if I just go back and say 50 underscore startups, then it works. All right, it works. So first of all, it gives me the top five things about that. We've seen that already, even back there. We say RD spend, administration, marketing spend, state and profits. So if you want it to show 50, like we always like to do, so it shows you all the 50. And so these are all the these are all the startups now, thankfully. So if you have more than 50, just show the first 50 for sure. And of course, this also tells you have 50 entries, 50 data points, labeled from 0 to 49. And then you have R&D spend, you have columns, 5 columns, R&D spend, administration, marketing spend, state, and profits. And they are all float apart from state, which is objects. So floats, you can do calculations with them. Objects, you can only categorize or aggregate or group them together, basically, right? So, but you can do calculations with the rest of them. Okay. So we printed the first 5 rows. I mean, if I don't have this 50 here, it will just print the first 5 rows, you know. So if I leave it blank, it will print 5 rows. If I put 50 here, it will print 50. If I put 10, it will print 10, for instance. So now it's printing 10 labeled from 0 to 9. So if I leave it blank, it just prints the top five. Okay, just prints the top five, and then it also gives us an overview. So this is df.info. So it gives us an overview of the rows and columns and the memory usage. So we printed the first 5 rows of the data from using the df head function. That's fine. So let's go ahead and talk about creating a line plot. What about you want to create a line plot? So let's create a line plot of the data using Matplotlib. So you see, you have seen the column, the variable names, very important because those are the things you're going to be using for your plot as you go on. So here now, I want to do a simple line plot where, I have X is R&D spend, Y is profit. So I want to see how does the spending on research and development, how does it determine profit? That's what this line is going to show us. And then we say plt.plot. You need a line plot, so we just say plt.plot X against Y. Line width is 4. We can change it like we saw before. We want the color to be blue because it's just one line. Or you can make the color whatever you like. You can make it red or green or blah blah. So then the title, line plot of 50 startups. Font weight is bold. Font size is 14. So you can change all these things as you like. Like you want the font size to be bigger. This is where you do all of these things. Then even the labels and all that. So if I run this now, see what we get. So this is what the line plot looks like. So I mean, R&D, the higher R&D spend, the bigger the profits. Okay. So the higher the R&D spend, the bigger the profit. That's one thing. So for those who have zero R&D spend, of course, they still have some profit, right? They still have some profit, but the people who really spend on research and development, make better profits for sure. Okay. So I mean, I can change this now to say, what other column do we have there? We have administration. So I can just put administration here. I just want to do that briefly. Administration. So how does the amount spent on administration, how does it affect? Okay, this one is R&D spend against profit, right? This is Okay, how does R&D spend affect administration? So it's all over the place, right? R&D spend so profit instead of this profit now, I've changed it to our administration, so it's fine. So let me change it back. Right. So instead of R&D now, how does administration spending, like spending on administrative duties, administration. So the spelling must be right. So, so the administration, it's neither here or there. Now we are talking about how R&D spend is now administration, mind you, not this one now. So administration against profits, right? So there's no clear pattern, so it just keeps being that way. So let's take it back to what it was. Okay, so this is what we've done here. All right. So we move on to creating a scatter plot. So like I said, now we are using scatter plot for these 50 underscore startups now. So let's do a scatter plot of the same thing we have done up there. So no need to tell too many stories. So I mean, it follows the same pattern like a line plot. The only thing is that it doesn't join things up. It just shows us the dots all over the place. So scatter plots are very nice ways to quickly see relationship between numerical variables, like we know. So we have research and development spending. How does it determine profits? And we have the scatter plot, which the shape is just like that line plot we did previously. Then how about creating a histogram from this? Maybe we want to create a histogram of the states, right? Like how many of the startups are from each of the states, right? So because histograms are very good for counting, for instance. So we have our variable is the state. So y is equal to df. df state means extract the state column and give us a histogram of it. Line 5 says give us a histogram of the state column, and the bin is 5, so we can adjust bin and all that, right? So we have histogram of sample data. So see now, so it means we have like 17 of the startup from New York. We have about a bit, I think a bit above that, or they're about the same from California, and Florida is not as much as New York and California, right? So we can talk about the beans. Let's say the bean is three. So I mean, when it's three, everything joins up. So it doesn't make sense. What about if we make it 3.5? Does it work? It doesn't. It doesn't seem to use fractions, right? So we can say four. Okay, we have four. Oh, even four is things are still joined together. Okay, five is like the ideal thing, but I mean, if you go 50, it gets really tiny, right? So, but five seems cool. Let's do 10 and see what that looks like. Okay, so five is just cool. Let's do six. Six is still like this. So you can, I mean, you have your choice. So you have that now, the bars. So the smaller, the bigger. So you can also create bar charts. Just like I said the other time, histogram is bar charts joined, right? So we want a bar chart of profits, right? Like that. So we are creating, so we have a range of the length of the profit, right? So that is what this is going to give us. So for each of the 50, for each of the 50 startups now, this is how their profits look like. So the first one, the profit is this high, followed by this, and up to the 50th one. So that may be not so, that may be counter, not so intuitive, right? But I mean, that's one thing we can do. We can also talk about creating a stacked bar chart. Okay. So here now we want to create a stacked bar chart of the Z1 and Z2 columns in the data using Matplotlib. So let's say we want to stack marketing spend and administration, more like a comparative, want to see which of them takes the bigger share of each startup's activities, right? So, I mean, you can look at all of these things. I hope it's big enough. So Z1 is administration. So we Z1 DF administration means extract the administration column for Z and call it Z1. Z2 extract the marketing spend column and call it Z2. And then we want to plot the bars now. So the range, we need the length of Z of the whole Z1 for each startup and for Z2 for each startup, and then we label them and we stack them on themselves. And so it's these bars now that, so you see, how does the stacking take place? So here we have Z1 label administration, but here we now have Z2, and then at the bottom of Z2 now, at the bottom, you have Z1. So you have Z1 administration below, marketing spend above. That's what this means. So we can switch it over. I can come back later and do the switching. So see what happens here. So you see that the administration is at we said the bottom should be Z1 and Z1 is administration. So you have the administration below and the marketing spend above. So you see for the first startup, they spend more on marketing than administration. And then in fact, then do we, so imagine this startup now close to 20, they spend nothing on marketing, they spend on administration, this one too, they spend nothing on marketing. Now look at this 50th startup, they spend more on administration than marketing, and so on and so forth. So I could also just so if I could also put Z2 at the bottom, right? If I do Z2 at the bottom, so it just switches over, although they are not stacked over themselves. So I may have to, adjust that, right? So let's keep it the way it is originally. So you can have a stacked bar chart. Then another thing we have is pie chart. So how do we do stacked bar chart? Nothing special, just bar. We use the normal plt.bar twice, and then we just say which one should be at the bottom and which one should be at the top, basically. So creating a pie chart. So let's create a pie chart of the Z values in the data using Matplotlib, right? Now, mind you, here I'm now using I'm using the people.xlx. We used that a couple of times. So there's a data set here called people. I think everything you can download from the link in the description. So this is the people stuff where you have okay, no, yeah, you have name, age, city, and salary. I think we've used it a couple of times. So so this is what this looks like, right? And of course, there are some missing values. So to create pie chart, I'm using that particular one now. So, and that's why I'm starting afresh to use that. So, I've been using DF for the previous one, so I'm using the same DF. So, now, and this new DF automatically overwrites the previous one. Another thing I could do is just to change it to maybe DF1, but I don't care. All right. So in this case, now you also need to know what that data set looks like, right? So see what's happening. Assuming you have already imported pandas and your data is in people.xlx, which is behind there, right? So I say df.people.read xls people like that. So I'm dropping duplicates, I'm dropping not available values. We've done this under data cleaning. Then we print. So print df. Now I want to see what it looks like. Then zdf is salary. So based on that salary, I want to plot figure. I want to plot pie chart of the salary. I want to distinguish based on city. I want the percentage to want it to be in percentage with two decimal places. That's what all of this is about. So I just run this, and then it shows me the what that data set looks like after I have cleaned out all the missing values, dropped duplicates. So see what we have now. Okay, so we have the colors represent the cities, just like we have up there, and then the percentages are on the faces. So we're actually doing the pie chart of Z, which is salary. So this shows the percentage each of the centers take of salary. So the biggest of them all, I think, is 19.96. So Natal in France takes 19.96% of all salaries paid in the company. I think followed by Paris. Yeah, Paris is another city which takes 19.68, and that is followed by Madrid, which takes 18.74%. We have Gainesville taking 11.53%. We have Paris, another Paris. That must be like another Paris. I guess the Paris should have been aggregated though. But yeah, we have Paris taking, because we are doing it by city, right? We have another Paris taking 11.25%, and then Lagos is taking 9.37%. So we can do pie chart that way. Okay. So we can also do a box plot. Box plot in particular helps us to see outliers very easily and the range of values that the salaries actually take. So here now, so the keyword, like for pie chart, right? What the key thing is this plt.py, right? PLT. So we've seen plt.plot, plt.hist, plt.scatter, and we are seeing we've seen plt.banner, we are seeing plt.py for pie chart. So for box plot, we have plt.boxplot, right? So we want to do a box plot of salary. So look at what the salary range looks like. So it's really scanty. So the median salary is something very close to 120,000. All right. So the data is not that robust. So that's why we're not seeing so much, right? But we could, okay, let me not distract myself with that. But everything I'm doing here, you could do again with the startup data set. So uh, so here we are creating a scatter matrix. So a scatter matrix is a collection of scatter plots that allows us to see the relationship between multiple variables. So you want to see all the relationships in one place at the same time. That's why you use scatter matrix. So let's create a scatter matrix of the XYZ columns in the data using Matplotlib. So XYZ, you know, uh, for all the data. So let's see. So we just come here and say that we want scatter matrix of age, city, and salary. We want to see everything together, and we want the diagonal plots to be histograms. And then we can have the scatter matrix. So here you have subtitle scatter matrix of sample data. So if I do this, so you see, so you have the histograms here. Now here, the relationships are not so clear because the data are just really scanty. Well, that's just an example. So if we do the 50 startups, so I'll go back to the 50 startups now, and we do the same scatter matrix, we get more things because we are comparing R&D spend, administration, and profits. So if I do this now, yeah, we have something clearer. So here we have clear pattern between R&D spend and profits, which is the same like this. So, but for administration and R&D, nothing clear. For profit and administration, nothing really clear. But profit and R&D spend is really clear that the more you spend on R&D, the more you have the profit. So it's more like the same scatter plot we've done the other time, but with for all the variables you have selected, right? So you have everything in one place. So again, we are going back to the people.xlx. So creating a violin plot. A violin plot is a visual representation of the probability density of the data. So, density talks about, so the thicker one side, the more the data you have there, and or the wider the distribution as you see what a violin looks like as you're going to see pretty soon. So let's create a violin plot of the Z values and the data using Matplotlib. So here, now I'm bringing the people.xls data again, and I'm dropping all the duplicate. I'm doing data clean, drop, duplicate, drop, not available values, and then we are visualizing the salary, and we are doing it into a violin plot. So in that case, that will PLT the violin plot of the salaries, right? So that shows us the spread of the salaries. So you see that the biggest salaries is where you have the biggest spread. So it means the salary, the biggest, most people get salary around this 120,000. So that's why it has the wider part, right? So around 160,000 to 180,000, you have fewer people, and then you have some top people still getting a bit more, right? So that's what this is about. So if we do the same thing for the startups, talking about the profits now, how does the profit spread? So you have most of the profits is around something a bit between something between 100,000 and 125,000. That's where most of the profit lies. And that so it shows you the distribution of the profits for the 50 startups. So most of the startups make profits between 100,000 and 125,000. And then it just trims down like that. That's what violin plots do. Now, when we go to Seaborn, Plotly, and all that, you're going to see more things like that. So, having talked about all these possibilities, I mean, it is not exhaustive. There are more things you can do with Matplotlib. So, let's talk about saving visualization in Matplotlib. Mind you, we don't have anything saved in the folder like I showed you before. There's no figure, there's no plot so far. So for each one we save, I'm going to go back, come back here and show it. So once visualization is styled and complete, once you do your visualization and you are satisfied, doing all the adjustments, making it the right colors, and doing all that. So uh, saving it properly ensures it can be reused, shared, or included in reports. So maybe you are writing your thesis and you want to include pictures, so you need to save. So if you now save, you can now put it in your Word document or LaTeX document or whatever kind of thing you write in. So Matplotlib provides flexible options to save figures in various formats, such as PNG. So you can save in PNG. PNG is one of my favorite formats. I prefer it to JPEG, by the way. PDF is even better. PDF make sure your picture quality is very solid. SVG if you're working with websites, and JPEG is the most popular. I mean, most of our pictures are in JPEG. But when it comes to drawing for research, I love PNG and PDF. So now for basic saving, the basic saving thing, you just need plt.savefig. Savefig is like the function that you get from Matplotlib to save. So to save the current figure. Note, always call savefig before show. So especially in certain environments, to avoid saving an empty figure. So if your savefig comes after plot show, you may not actually have saved the figure, right? So here now, I'm just making up stuff here. So I want to plot I want to plot 1, 2, 3, 4 against 10, 20, 25, 30. So these are just Python lists directly. So we have a basic plot here. So all we just need to do, we are saving as PNG, we just say plot plt.savefig basic plot. So what I want to call the plot is basic plot, and it's in PNG format. I can make it PDF, I can make it whatever. All right. And then we show it. So if I run this now, so it shows me the plot here, but then in the folder, it has now saved something called basic plot. So you can see we now have basic plot. I mean, the time is 2:47, so it's saved at 2:47, like just when I did that running. So you have the plot here. So I go back, and then what if you want to save with custom DPI with high resolution, which is usually recommended, especially if you want to print, if you want to make some printing, you want to print your whatever document you're putting the picture in. So you can increase the DPI, which is dots per inch, to get a sharper image, ID for publications or print. So if you want to print, you need the image to be sharper. So I just say plt.plot this list against this list and plot at your high resolution plot. And we now want to save this figure now as h high underscore res underscore plus. You can This name is up to you, but then this extension too is also based on your choice. So we are saving this in PNG again. Now we are adding that the DPI should be 300. The dots per inch should be 300, and I just run that also. So mind you, it has plotted, and then it would have saved in the folder as high underscore res underscore plot. So I come into my folder and I have high underscore res underscore plots like this. So you can see in a way it's a bit better than what we plotted before, the basic plot thing. This is the basic plot, and this is the high resolution one. So you can see the difference is really clear, right? So this is the high resolution plot because we have made it 300 dots per inch DPI. Okay, how about you want to save with transparent background? So you can create a transparent background useful for overlaying plots onto different backgrounds in design work. So if you are designing and you want to plot your plot over another plot, so you can make it transparent, right? So that you can I mean, it's useful to do that. So again, we are plotting two lists against themselves, and we call that transparent background plot, and we are calling that we say play.savefig. Line 4 is what is doing the deal. Savefig is the function from Matplotlib that helps to save your figure. And then now we name it whatever you want to name it, transparent plot.png. And transparent you want that to be true. And then you have show, so you have plot the plt.show. So you run that and you have this. Now it doesn't look transparent here right now, but where it is saved, it is transparent. So let's see, do you have transparent? Yeah, transparent plot is here now. So you see, look at the way it is. It's not showing the normal white background because it's not looking like these other ones that we had here. So you see the uh so this is the transparent thing because you can now overlay it over other things if as you're designing, right? So I go back and I say, what if you want to save with tight bounding box and padding? So here you want to reduce unnecessary white space around the figure by adjusting the bounding box and padding, right? So all you just need to do is plot the save figure, now add extra things to it. So you have b box underscore inches. You want it to be tight, so that helps you to reduce unnecessary white space around the figure by adjusting the bounding box. And then you also want to pad it. So you say pad inches is 0.2. So plot the show. We've run that now. You may not see the effect until you see it in the folder. What did we call that, by the way? We said that should be called tight layout plot. Okay. So we call that tight layout plot. So you have it right here now. So tight layout plot. So you can see the white line, the white side is not there. So you see this one has wide white line, but this one is because we don't want all the X. Any white line that is not serving a purpose should be gone. So sometimes you may need your plot to look like that. All right. So you can also save in different formats, right? So here uh we are still plotting 1, 2, 3, 4 against 10, 20, 25, 30. So we can now have multiple, we can save in different formats. We can save in PNG, PDF format. We can also save for an SVG format, which is good for web and scaling, right? So if you are using the picture on a web, so if I run this now, everything just is saved. So it shows the picture, one picture, right? But if you go into the folder, you can see plot.image for PNG. So you see plot.image. So this is the uh PDF format. So you can see how cool it is. Like PDF is particularly very good for high quality pictures. And good news, well, you may not be able to import PDF into Microsoft, but if you're using LaTeX, you can import PDF into it, right? But I mean, otherwise you can use PNG. So you have the PNG file here too, which is not bad too. And then you also have the SVG. You can see it's looking something like a web kind of thing, right? So you have all of that. So finally, can we do the administration and marketing spend thing we did previously for this now? So you remember we have administration and marketing spend. I want to do a stacked bar chart, and I'm saving it in all formats. Stacked bar chart of sample data, stacked bar chart of sample data in PNG, in PDF, in SVG. Mind you, in the folder, we don't have anything like that. Stacked, we don't have anything stacked yet, right? So, but once we run that code, it automatically saves like that. So I just put okay, this is what I'm running now. So I just say Control Enter, and then it takes a bit of time and returns that plot. Beautiful. Because here also I've also increased the DPI to 300, which is good, like that. And then I come here now, then I already have my stacked stuff like that. So PDF looking excellent, looking beautiful. All right. Then we also have PNG. We have PNG like this looking good. And then if you want to use it on the web, you can also have this. So with this, we come to the end of data visualization with Matplotlib. So we've gone through a whole lot. All right. So you want to, of course, you have all my documents, all my code sheets, all my data sets. You can find them in the link in the description box, either on Python, either on YouTube or Facebook. So you can download everything. In fact, before you start watching any of my videos on data analysis, the first thing you should do is go and download everything there so that you can follow. Because the best way to code, like I keep saying, is to code. The best way to code is to code. Don't just watch a video, and by the time it's time to implement, it's difficult to implement. So as I'm doing it, you can pause the video, do your own. You can copy that code out even, then change some things, tweak it, and see the effect they have. That's how you learn, and those things actually get to stick. All right, thank you so much for listening thus far. Let me know how helpful these videos are for you. Let me also know if there's a topic you like me to teach, or a problem you like me to solve. Or I mean, after all these visualizations series I'm going to do, like I'm going to talk about all the ones I've mentioned, like Matplotlib, like Seaborn, like Plotly, like Bokeh, Altair, and of course Plot9, which gives us some R vibes, ggplot2 vibes inside of Python. So after that, I'm going to be taking some kind of project, right? I'll just run through some data sets, draw insights from them, answer some questions and things like that. All right. So if you have data sets you like me to consider, actual data sets, or you just want maybe data sets in a particular realm, I can make them up and use them to explain to you. Okay, so feel free to let me know if there's anything like that. If you have subscribed to this channel, of course, you know you are learning a lot already. And if you have not subscribed, of course, you know you are missing. So go ahead, hit the subscription button right now, and don't subscribe and hit the notification bell so you can always get alerted each time a new video is released. Then be sure to like and share so that more people can have access to this great content we have here. Till I come your way again, keep doing data right, even as you've always done maths right. Bye.